Okay, let's get started. Hopefully my screen is visible to everyone. I think one common bit of feedback I receive is the VS Code theme. Let me change it to the regular one. Okay, cool. Hopefully that's visible to everyone well. All right, so we're just going to be going through a couple of questions from previous years on the topics that were announced. So we're going to start with conditionals and some miscellaneous stuff. And then we're going to move on to functions, recursion, loops, and then we'll finish off with structs. And if we'll have time, we'll revise a little bit of pointers so that you have some time to digest and recall it before the next session where we'll look at all the memory related topics, right? So there's pointers, DMA, file IO, these sorts of things. Okay, cool. Also, if there's any sort of network issues, you can message me on Slack so I know that you're not able to hear me or whatever. All right. So this is the first question, identify the type and value. Just a simple reminder of how implicit types work. So essentially what you want to keep in mind is that if you have these basic operations like, okay, apparently the meeting has a maximum number of participants or something. Let me have a look. That might be an issue. Okay, so basically, I think a maximum of 100 people can join this meeting, and there are quite a few more people who are trying to join. Just give me a few minutes while I try to see what can be done about that. Wouldn't want people to miss out on the session. Right? It'll probably just be another 2 minutes. Sorry about the delay. Okay, great. Now everything is set up, I think. Sorry about that delay. I did not see that coming, obviously. Okay, great. So yeah, the basic exercise on data types. So what I wanted to remind you of here is that when you have a certain numerical data type like an int or a double, and you add them together, then the result, as far as possible, is going to be of the same data type. So if you manipulate a bunch of integers together, your expected type of the result is going to also be an int. Similarly, if it's a bunch of doubles, then your result will be a double. Same with a character, and so on. And if you have a mix of ints and doubles, then your result will be a double. One other thing is that ints and can be typecasted to booleans, right? Bools. And essentially any non-zero integer is true, and any just zero is false. That's how you would interpret them. Okay, so okay, it looks like people can't hear me. One second. Okay, so let's hopefully that issue gets fixed. So let's start with this first one, m plus n times 2. So m and n are integers, and 2 is also a literal integer, right? So the type of this expression, this number 2, is also an int. So you would expect this result to also be of type int, and the value itself, well, that's down to your order of operations, right? So you would multiply first. So you'd have 30 for n, and 30 plus 10 is 40. Pretty basic. Now let's have a look at this. So here again, you're going to need the operator precedence. So let's just open it here. I've saved it for reference. So let's have a look. So if we compare, yeah, so if we see less than or equal to and division, you can see that division is of a higher priority than this relational operator, less than or equal to, right? So the division gets evaluated first, right? Okay, so you have n divided by m, and this is integer division, right? You have the quotient of two integers, and so your result is also going to be an integer. Now, just another big reminder, right? Because like this is the only other thing pretty much that can kind of trick you in this topic, is that remember, when you divide two integers, the result is basically the normal result, the whatever real number result that you would get, but with all the decimal places removed. So for example, here you have 15 over 10, that's 1.5 normally. But the integer division result would be what you would have if you remove the 0.5, everything after the decimal point. So this would be 1 in this case. You can also think of it as the floor of the regular result, of the regular division result. Anyway, so yeah, this is 1, and 1 is less than or equal to 1. So that's true. The type of this is either int or bool, whatever you want. And the value, it would depend on what you wrote, obviously. So if it's an int, then you would expect it to be just any non-zero number, right? Okay, similarly here, there's some more operator precedence to be applied. So equals is again not having a higher precedence than division or addition at all, right? So all of this, this would be, the stuff inside the parentheses would be evaluated. So 5 equals 5, that's true, right? And then m plus n, so that would be 25. Actually, no, my bad. So division would get evaluated first, right? So you would have 15 over 1, so that's 15, and then 15 plus 10 is 25. And then similarly here, the double X is getting involved. So your expected result is going to be a double in that case, right? So here there's no integer division or rounding to be worried about. M plus n gets evaluated first here. You have 25 and 25 times 2.5, which is 62.5, right? Yeah. And that would be your output or the value. And then here, similarly, the multiplication happens first. So 2.5 times 10, that's 25, plus 15 is 40. And you would expect 40.0 for the double value. Cool. Hopefully that makes sense. Let's move on to the next problem. Again, just to repeat, if you weren't here for the start of the meet, if you have any questions, you can send them in the meeting chat. You can also send them to Aishwarya or Pranav, the other two TAs, or me on Slack, and they'll help you out, or they'll pass your question over to me and I'll explain it to everyone on the meet. Okay, cool. Okay, let's move on to the next one. Just a reminder of the dangling else problem. I covered this in the final office hours session, but essentially when you have a bunch of ifs and elses like this, what gets attached where, right? So the way to think about it is whenever you have an if and there's no braces, right? So just to remind you, conditional is just a type of construct, programming construct, where we only want to run some code if some expression evaluates to true, right? And the actual code that we want to run, we usually enclose it in braces. So for example, I might write if n equals 5. So if this variable n is equal to 5, and then whatever code I want to execute would be within these braces, right? Now here, when you omit the braces, what happens, right? So usually it just eats up the next line. So for example, here, this if is going to attach itself to this one on line 8. So when, like, if a is greater than b ends up being true, then this line will run, right? Now, when this line is true, then this one runs. And that's it, okay? So this is completely separate from these, okay? So again, it's only like a one line sort of attachment, right? So this this encloses this if, and this if encloses this. So you can think of it, if you were to add the braces for less ambiguity, you would visualize this code as something like this. Okay? So when there's no braces, they only associate themselves with a single line, and that would be the immediate next line. Okay, now what about this else? There's like 3 ifs here, right? So which else would this, which if would this else apply to? So the rule there is the else attaches itself to the last unattached if. In that case, that would be this if, okay? So you would visualize the braces like this, okay? So then evaluating the actual output should be fine. So if A is greater than B, it is. If C is greater than B, it is. So 1 gets printed, right? Then C is equal to A, it is. Then 2 gets printed. And this 3 does not run because this condition, C equals A, was satisfied. Okay, so 1 and then 2. Hopefully that's clear as well. Great. Now let's move on to, I think, the most important topic for today, which is recursion. I think recursion is always the one that can kind of get you, no matter how much you practice. So I did hold some of the office hours were on recursion. So I'll just be reiterating some tips that I gave there as well. And let's start with this problem here. Yeah. Okay, so the problem is asking you to basically write down the output. Right? So again, a lot of your questions in your Compre are output-based questions, right? Okay, so in main, you define some variables. Here's an array as well, and some variables. And then this function recurse is called. And over here, this recurse function is recursive. So let's have a little bit of a reminder. What is recursion at all, right? So basically, there are some problems, the sort that you can solve with computer programs that have some size associated with them. Okay, so an example of that might be, let's say, the sum of like n numbers or the product of n numbers, right? To keep it simple. So then the size associated with this problem would be the number of numbers that you're dealing with. So okay, let's just stick to a specific example, like finding the product of n numbers. So you're given, like, let's say, an array of n numbers, and you want to find the product. So the size of the problem is the number of numbers that you need to multiply. Recursion is all about expressing this problem in terms of a smaller version of itself. So how can I express this problem of multiplying n numbers in terms of multiplying some smaller number of numbers, like something less than n, like let's say n minus 1 or n minus 2 numbers. And the idea is that if you keep applying this reduction, right, this technique that reduces the size of your problem, eventually you'll reach a problem whose size is so small that you can solve it very easily, it's pretty much instantly. And you'll recall that this was the so-called base case in your recursion, very much related to the recurrence relations that you see in math, right? In fact, if you're solving a specific math problem with your program, then you'll find that whatever you write in your recursive function will pretty much be the actual recurrence relation itself, just written in C instead. Okay, hopefully it's ringing a bell for everyone. Let's get started. So I like to think that there are kind of two types of recursion problems that you see in this course. One of them is where you need to trace the function calls, right? So for example, here, this printf calls this recurse function, and then recurse calls itself here with some different parameters, and then so on. And you would need to just go line by line like you usually do and find the output, right? That's the first type of problem. And the other is where you can actually see what the problem is that this program is aiming to solve recursively, right? So by observing this code here, for example, what this return value is or what this is calling here, you can get a recurrence relation or otherwise describe what the point of this program, the point of this function recurse is without having to trace it, I mean. And if you do that, then you can just solve the problem yourself without having to write out a bunch of function calls, and then you write down your answer. So I'll give you an example of both. This one is where you don't have to trace all of the function calls. This is an example of that, but we'll do it both ways, all right? Okay. So first of all, let's do it the sort of manual way by tracing all of the calls. So again, first of all, this result gets defined, this array gets declared, and you have n, which just acts as the length of this array, just storing the length of this array. So recurse is called with this array and its length. That's all the purpose of this is. Now, here the value of n is 4. So let's just note that down. And n is not 4 in the initial call, so this doesn't run. Now recurse gets called with the same array and the number 3 instead from this. So again, now to visualize this, I'm going to use the visual debugger, if you recall, from one of the non-eval labs. And what's really nice is that it actually pretty much lets you see what all functions are being called. So let's just have a look at that. Okay, lovely. 1 second. All right, I need to, sorry, give me a moment. Okay, so the visual debugger shows you all of the functions that are currently running in your current execution of the program. So for example, you can see here that the main function is the first one that gets called, as you know, and main has then called this recurse function, and in recurse, n is 4, right? And a is this array. Okay, now when I move to the next step, so I've added a breakpoint here so that whenever the function gets called, I'll be able to pause at that part of the execution. So now if I go to the next step of the execution, you'll see that another call of recurse has started. And that was just when the recurse that was called with the array and n equals 4, this called recurse with a and 3, okay, from this line here. So what that means is that the recurse with a and 4 is currently paused on this line, waiting for this function to return. And now this recurse call with a and 3 is currently running, and it will again reach this line and call same function with a and 2. Okay. Yeah, so now n is 2. And then again, it gets called and n is 1. Now, when n is 1, this part of the if gets run instead, and it returns the n minus 1th element in the array. So what would that be? Well, n minus 1 is 0. So a0 is just the first element, which is 1, right? So 1 gets returned here. Now, in the function call above, right? So we look at the function call with n equal to 2. This function is paused here. Now, when a1 returns, r will obtain the value of 1, right, that we just saw. So now in this particular call with r equal to 1, recursive a2 will return this expression. So we can see exactly what that expression is. It's 1 times n minus 1. In this call, n is 2. So 1 times 1, and then plus a n minus 1. So a n minus 1, that's a1, which is 2. And then this divided by n is 2. So just divide this by 2. And the result of this is 3 over 2. Now, what would the type of this return value be? Well, you can see it here as well. But even without that, this expression is a bunch of, like, so you have one double and you have a bunch of ints. So you would expect the result to be a double from what we discussed earlier. So you would have 3 over 2, which is 1.5. So recurse A2 returns 1.5. Then in A3, which is paused on this line, R becomes 1.5. And then similarly, you multiply 1.5 by n minus 1. So if we write that expression out, 1.5 times 2 plus an minus 1 in this call of recurse, that's a2, which is this element here, right? 3. So what do you get here? 6, and then 6 divided by n, which is 3. So you get 2.0 as your return value. Then finally, in the first call of recurse, which was with a and 4, R gets assigned 2.0 after A3 returns. Then you multiply 2.0 with n minus 1, which is 3. You get 6. And then 6 plus an minus 1, which is A3. A3 is the last element, that's 4. So 6 plus 4, 10. And 10 divided by n, which is 4. So that's 2.5. So recurse an here would return 2.5, and then you're printing that to 2 decimal places. So 2.50 would be your output. So let's just resume continuing through the execution. You can see all of these are returning one by one. And in this final call, this happens. And yeah, you get 2.50 as the output. Because that's how you trace it manually. Before I move on to the other way of solving this problem, does anyone have any questions? You can put it in the chat. Does anyone need me to go over the whole tracing part again? Just let me know. Sometimes sometimes sorry, one second. Yeah, so sometimes writing all the function calls can be pretty tedious and it's easy to make silly mistakes, but um, in most problems, all you need to keep track of is all the local variables, right? You need to keep them separate to each other. So in one call of recurse, the value of n would be different from some other call. Similarly for the value of r. So in your rough work, if you get them mixed up, then that leads you to basically making some silly mistakes, right? And sometimes these local variables make a huge difference in what's actually going on. So if you lay your work out neatly, you just need to keep track of two things. One is which function calls are currently active. And for each call of the recursive function, what are the local variables values? And keep updating them as you do. Essentially, you're just emulating this visual debugger. So you can see that at every breakpoint, I'm able to view the local variables, right? You can ignore this R value. This is actually a garbage value because R hasn't been assigned to anything, or nothing has been assigned to R yet. But you can see that I can view N, right? And that the value of N is the most important for most of these calls. And then when all four of these start returning, that's when R gets assigned to something, right? Okay. Okay, someone asked to go over the tracing once again. Let's quickly go through it. Okay, so here the only local variables that you have are this n, which is the length of the array, and r, which is this double that you're defining here. Okay, so in the first call of recurse that comes from main, you have this array which is not being changed at all by any code here. So you can treat that as just like a constant, right? You don't have to keep track of it in the individual calls. The array just stays the same, right? You know that because you can see that none of the code here modifies the array in any way, right? You're not assigning anything to a particular spot in the array. Hopefully that makes sense. Okay, so in the first call, R gets assigned to something, but you don't know what that something is because this function needs to return first. So then recurse of A and 4 calls recurse A3, right? You can see N is 3 in this second call of recurse. And then that calls A2, and that calls A1. In A1, you've reached this conditional where N equals 1, and this just returns a number. So now that you have a numerical value for one of the function calls, you can start heading up back this chain of function calls and find the value of R essentially at each stage. So here, recurse A1 returns, and that gets assigned to the value of R and recurse A2. So if you were tracing this, you would basically scribble out your function call for A1, right? And then you would, under your recurse call for n equals 2, you would write that R is now equal to A0, which is, yeah, it's 1, right? So you would assign R to 1, but only in your recurse of A2 call, this one right here, right? And then you would calculate the value on the next line with the specific value of N for this call, right? The local value of N, right? So here R is 1. So 1 times 1 plus A1. So that's 3 divided by 2, which is 1.5. Then the R in the next level up, right? The next highest call gets assigned with that value, right? So if we just continue. Yeah, so R becomes 1 for recurse A2. And then in recurse A3, R becomes 1.5. Then in this final call, R is 2. And if you calculate this expression in recurse A4 with this value of R, you get 2.5. And that's why 2.5 gets printed here. Okay, hopefully that was clear. Okay, now the other way of solving this problem, which is if you're feeling a bit lazy, you can try to identify what the actual recursive problem is. So for example, if this code were the code for multiplying n numbers, let's say, it's not, but let's say that this code found the product of these, all the elements in the array. If you were able to identify that, then you wouldn't have to trace each of those calls. You would just directly compute the product and then write that down as your answer, right? But for that, you have to be able to convince yourself that that's what this code is actually doing. Okay, so let's think about what's going on here. So in this base case with n equals 1, you take essentially the first element of the array, A0, and then you do something with it. This expression is key. So R is the return value of the previous call. So if we replace R with recurse A n minus 1, I'm just gonna call that, okay, actually I'll just call it recurse A n minus 1. Or I'll just say n minus 1 because the array is constant, right? You basically only care about the value of n. Okay, so you can see here that the return value for recurse an is equal to this R, which is recurse n minus 1, times n minus 1, plus an minus 1, which is the value in the array, right? Then all of this divided by n. Okay. So this is recurse n. So looks a little bit far-fetched. Actually, I think I would get the intuition on this from tracing maybe the first 2 calls, and then I would see what it was doing, and then I'd be able to spot this. Essentially, this is finding the arithmetic mean of some portion of the array. So recurse n finds the mean of the first n elements in the array. If I say that, then probably it becomes clear how this recurrence does that, right? The mean of the first n elements is the sum of the first n minus 1 elements, which is this, right? The mean times n minus 1. And then that plus the next element, right? Remember that an minus 1 is actually the nth element, right? We're using 0 indexing with arrays, and then divided by n. So hopefully that's clear how this recurrence represents finding the mean of n numbers. So if you were able to spot that, you could just write down 1 plus 2 plus 3 plus 4 divided by 4, which is 2.5. And then you wouldn't have to trace all of those function calls. Is that clear? Does anyone have any questions? Great. Here it's very sort of mathematical, but I think in other cases where it's not explicitly computing something with like math operations, it can be easier to spot what's actually going on. Like if you're looping through some string or something. Anyway, we might see more examples of that in the next session. The program being explained, what if the function recurse is of type int and a double value is returned and vice versa? Okay, so here, if this were defined like this, then whatever you return here will get typecasted to an int implicitly, okay? So if you were to write this, then 2 would get printed instead of 2.5. Okay, I can actually run the program and show you that if you want. Okay, never mind. Actually, that's okay. I oversimplified that. So if the return value is an int, then this double will also get assigned an int value, right? So it's not that simple. You'd have to trace the whole thing over and over again. Yeah, so then it wouldn't be, you would have to trace it manually in that case. Never mind that. But yeah, then if the type were double and you returned an int, then it would get typecasted to a double. No data loss or address problems in truncating or promoting. No, not at all. You can always typecast doubles to ints and vice versa. Obviously, there is some loss in precision, in accuracy, right? When it comes to the actual value that you obtained from your calculation versus what you're returning. But memory-wise, there's no issue at all. Okay, hopefully that answers your question. Okay, let's have a look at another recursion question. This one here. I'm afraid there is no neat recursive problem that this is solving, or at least not one that I could spot. If someone spots, then please tell me. I'd be very interested in that. So the only way then to do this is to trace all the function calls. So let's have a look. There's no arrays or anything involved in here. It's just this function being called and some operations going on. Okay, so main gets called when the function first starts, and main calls a12, right? Now, when it comes to the first call, right, if I just note down what functions are currently active, and then I'll go through it on the visual debugger as well after this. So a12, if we look at this first conditional, so not m, right? So m is true, right? Because it's non-zero. So not m would be false. So this wouldn't run. This part wouldn't run. Now, if we look at this next part, if not n, this isn't true either because, I mean, basically neither m nor n are zero. So this wouldn't run. So then this would be the return value of a12. And this is a call of a with m-1 and this number, which is again unknown at this moment. So a12 calls a0 something which we don't know yet, because that expression needs to be evaluated. And that expression is actually the function, another function call itself, which is a11. Okay. So essentially, a11 will need to return, and then we'll know what the second parameter of this call is. Okay. This exact same thing happens with the next call, like 1 and 1 are, neither of them are non-zero. So both of these conditionals will get ignored, and then the same thing happens. Okay. So again, you have a0 something. And the second parameter here is a of 1, and then the n in this call, which is 0. Okay. If you're unable to see where I'm pulling the m and n values from for a particular call, don't worry, we'll go through it with the visual debugger as well. This is just so you can see what the sort of chain of calls looks like. Okay, now we have a10, and not of n is now true, right? So this part of the conditionals will run. So this should return a m-1 and 1. So that's a01, right? So you can see in that particular call, a10, m was 1 and n was 0. So this call is this. Okay. Now let's look at what happens with a01. Here m is 0, so this part gets run and returns n plus 1. So what is n plus 1 in this case? 2, right? So a01 returns 2. Okay, so the return value of this is 2. Now, if you remember where this call came from, it was from here on this line, right? A10 called A01 from this line. So now A10 will just return the return value of A01. Hopefully that's not too confusing. Basically, A10 is saying return whatever this is, right? And by calling that function, we found that that expression's value was 2. So now A10 will also return 2. And remember that here, we didn't know what the second parameter was because the parameter was itself the return value of a function. Now we know what that return value is, it's 2, right? So now we know what the parameters for this function call are. So we can actually execute that call itself. So A02 now starts evaluating. And here M is 0, so not M is true, and this part gets run. So A02 returns 3. Okay. Now where did A02 come from? That was from A11, right? Again, the same sort of thing, right? So now we would so A11 was the call basically that, fine, So A02 returns 3 and A11 should then return that value. Just give me a sec. So A11 called this and then ends up returning that value itself. So A11's return value is also 3. Now A11 was called on the inside of this second parameter here. So now this call here ends up being A03. Again, very similar to how we obtained A02. Now we can call A03 itself. And if we just go back to the start, right, and see what, so just to remind you, when you call A12, neither of these run, and this calls A0 something, right? So now we know what that something is. And when we find out what the return value of that is, that will also be the return value for A12. Okay, so again, basically once we obtained this return n+1 at this final call, it's basically a bunch of like returns being passed up, right? So this 2 got returned here, then got passed to this function, and this returned that same number, and then here n+1 got returned, and then that 3 kept getting passed back up the chain of function calls. So here now if you see what happens with A03, not M is true, so you return n+1, which is 4. So the final return value would be 4 for A12. Hopefully that's clear. Now let's go through it with the visual debugger. I need to actually, one second. Okay, so you can see the answer actually is 4. Now I'm going to put a breakpoint here. Hopefully that works. Does it work? Yes, it does. Okay, so every time the function gets called, the A function gets called, the visual debugger is going to pause on this line. Okay, so that should work fine. Right, I should probably keep, okay. So now I'll bring this text back and we can follow through with these calls and see how it's actually following them. Okay, so A12 is the first call, and A12 calls A0 something, right? Just one sec. So what's happened here is that before A03 can get called, this parameter needs to be evaluated, right? As I said before. So when I wrote it down earlier, I just kind of wrote it like this, but actually what's going on is this call occurs way before this one does, right? I mean, that should be natural, right? You would need to evaluate the parameters before calling the function itself. Okay, so A12 calls this, but you first need to find this 3, and that function call is A11. So you can see now A11 is the next call that started. Okay, now again, neither M nor N are 0. So this happens again. A0 and then an unknown parameter, which is actually just another function called A10. So the next call that happens is A10, you can see here. And now that N is 0, not N is true, we go to this part of the function. And the actual call that happens is A01, right? According to these local variables, right? So then next you can see the function that comes is A01. And A01 returns 2, right? Yeah. So now that those functions returned, you can see that this A0 something, which we previously didn't know what the second parameter was because it was the return value of some function. We now know what it is. So then that function gets called A02. Right? That was the next line that I wrote here. Then once that finishes off, A11 also returns that value. And then we finally know what the second parameter of this call was, A03. It was 3, right? So now that follows through and returns 4, right, on this line, because M is 0. And then finally, A12 also returns 4. And then that gets printed. So that's how we're getting 4 as the output for this. Is that clear? I'll just wait a minute so that people can ask questions if they need to. It's a bit difficult to show like the function calls and like the local variables and all when I don't have a board. But hopefully between the visual debugger and me writing or typing the function calls like this, hopefully you're able to understand, right? I can always repeat and trace the function calls again if it's confusing for anyone. This is what will take the most time. I guess the other problems are not too bad. So if you have any questions, make sure to ask. I can always go over it again. Okay, looks like we have a question. Can you please put braces in? Okay, yeah, sure, yeah. Remember, all the if statements do is, by the way, the code that I've typed here is the original problem. So you should be able to figure out where the braces would be to show the same behavior, right? Otherwise in the exam might be a bit difficult. It's just this, right? So as I said before, if there's no braces, these if statements just eat the following line, just attach themselves to the following line and nothing else. The next one line of code is taken as your conditional code, right? The code that runs when this not M evaluates to true. Yes, that's what Pranav is saying. Yeah, so again, just this is like the one-stop problem for all if-related issues and trickery, right? That they try to do in the exams when they don't give you the braces or the indentation, right? So the two rules that I mentioned before were all covered here, right? So first thing is the if attaches itself to the next line. And the other thing is that if you have a else all by itself, it attaches itself to the last unattached if, right? Yeah, so if there were two else's here, what would happen? So, I mean, just as a hypothetical, right? So if I had else and something, something, this else would attach to this if, right? So then what would this else attach to? This one, right? The last unattached. The last else, the last if that doesn't have its own else, right? Okay. Yeah, so these two rules are basically foolproof. for you to solve these problems. Okay. Okay, if no one has any questions, I'll move on. Okay, wait, looks like someone has a question. How did you get the M and N values A12 to A0 something to A11? How do you get the 11? Okay, let's have a look. A12, A0, where is it? Yeah, here. Okay, so when A12 gets called from main, that's clear, right? Now, when A12 gets called, see, basically these two conditions are checking whether M is and N are 0 or not, right? If M is 0, then not M evaluates to true. And in that case, this if will run. Same thing for this. So it's just checking, is M 0? If not, is N 0? And if neither are the case, then this is the value that's returned. Right? So here for the initial call, both M and N are non-zero. So you basically ignore these, right? And if you see what parameters A is being called with here, it's A, 0, and then this. Right? Now what are M and N minus 1? They're 1 and 2, right? Okay, but M is 1 and N minus 1 is also 1, right? So you basically need to call this. But before this outer function can be called, this inner one needs to be evaluated. So when I said A0 something, I mean this. We don't know the literal value of this, right? So now we know it's 3, but in the beginning I wrote it like this, right? So what I'm saying is when your compiler, or basically when you run the program and it tries to call this function, it will first need to evaluate this. And that amounts to actually calling this function with parameters M equal to 1 and N equal to 1. So that's how you go from A12 to A11. Make sense? Hopefully that answers your question. Okay. Okay, that's it. Let's move on to the next question. Okay, that's all we have for recursion for now. We'll do more recursion problems, but those will involve some pointers and stuff. So I'll do them in the next session. These were the problems I thought were nice that didn't involve any pointers or anything. Okay, let's go to loops then. So start with this problem. So just a reminder, a loop is just like a conditional. It's a programming language construct that allows us to accomplish something. With conditionals, the thing that we were accomplishing was being able to run some code only when some expression evaluated to true, right? And ignoring it otherwise. And with loops, what we're allowed to do is repeat some block of code a certain number of times, right? And the way you specify that number of times is completely up to you. So we have two loops to that effect for allowing you to specify the number of repetitions, right? So the first one is called a while loop. And in a while loop, the code block inside the loop, right? So where you specify with the braces, runs until this condition is false, right? So if I write while false, then this loop will never run. If I write while true, this loop will run forever. The code inside will keep getting repeated over and over again, right? So you could replace true with whatever expression you wanted. And then based on the actual behavior of your program or what your goal is, the loop would eventually stop. And then the second type of loop is called a for loop. For loops are more for when you want to repeat something as a fixed number of times and you know what that number is in advance. So maybe in some cases, you don't know how many times explicitly that your code needs to be repeated, but you know that if some condition becomes true, then you need to stop the loop. So that's where a while loop is handy. And if you know the number of times explicitly, so for example, if you have an array of length 10 and you wanted to visit every element, you know that you would need to maybe repeat some code 10 times, once for each element, right? So that's where a for loop is more useful. And a for loop allows you to declare an index variable in the parentheses. So normally we use the letter I for that, I for index. So the first bit of code here is initializing your index to whatever value it needs to start at. And again, the index just keeps track of the number of repetitions, right? Obviously, depending on your program, you could make it do something else entirely. I'm just talking about how loops are generally used. Now, the second bit of code, the second statement is to specify when the loop should stop. So here you say when I is less than n, or sorry, not when the loop should stop, when like what is the condition under which the loop should keep running, right? So when this becomes false, the loop would stop. So similar to the while loop condition in that case. And finally, here you have some code which will run every time a new iteration of the loop is started. Right? So let's just go through this example, and I think whatever is not clear from my abstract description, my general description will be more clear. Okay. Okay, so here this array of integers is declared of length 10. Remember, an array is just a type of way to store some sequence of values of some particular type, right? So it could be a sequence of integers or of chars or whatever you want, right? Just some sequence of values, and all of these values are of the same data type. And the effect is that all of these values end up next to each other in memory, and you can access them easily. And also, you don't have to create a variable for every single value. You can store them all together. Okay, so here we declare this array of 10 integers, right? So we have basically a sequence of 10 integers. There's this integer I declared here as well, and n, which is 10. So n basically acts as the variable storing the length of this array, right? And here we have a for loop. So I gets assigned to 0, and this loop will run while I is less than 10. So it's gonna run once, essentially for every element in this array, and plus plus I. So every time this line runs, I is gonna increase by 1 afterwards, right? So if we just go through a few repetitions of this code, I starts off being 0, and then S0 gets assigned to 0, because the first element becomes 0. And then similarly, so that's one repetition of the code, right? So once this repetition is finished, I, like plus plus I gets run. So I becomes 1. And then this condition is checked, right? Is the condition still true? It is. 1 is less than 10. So then this gets run again. S1 equals 1. That's the idea. I'm sure most of you are like up to date on this, or like after my small explanation, you recalled it all. So I don't want to spend too much time on that. If you have any questions, again, as always, just ask on Slack or whatever. Okay, so this basically assigns these values to the array. So you have this array here, which looks like this. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So this runs while I is less than 10. So the last I that satisfies that will be 9. And so your array will look like this. Okay, so 0 through 9. Okay, now let's look at this next loop, which seems to be doing the important stuff. This loop just prints all the elements of the array. So this is the main part of the problem that we need to solve. Okay, so equals 0 and I is less than n over 2. So n over 2 is 5. So I starts at 0 and goes up to 4. So 0, 1, 2, 3, 4. So we have 5 repetitions of this loop. What's going on? First of all, Si gets modified in some way, and Sn minus 1 minus I gets also modified, and then this happens again. Okay, so what's going on? So let's pretend that Si stores this value A. And let's say that Sn minus 1 minus I stores this number B. Okay, so I should probably write this better. Okay, so I'm just labeling these array values here. So whatever is written here represents the value stored at this point in the array, and similarly here. And we're just going to keep track of what happens when we run these 3 lines. Okay, so the first line, Si plus equals Sn minus 1 minus I. Okay, so what happens? This is the increment, or basically the compound addition operator, right? So Si equals Si plus n minus 1 minus I. So whatever is stored in Si, B gets added to it, right? So after this line, the values look like this. Then Sn minus 1 minus I gets assigned to this. So Si, which is now A plus B, minus this, which is B. That's just A, right? So after the second line, the values look like this. And then finally, Si minus equals Sn minus 1 minus I. So you subtract this value from this. So what do you get? B. So what do these 3 lines do? They just swap the 2 values, right, at these 2 positions, I and n minus 1 minus I. It's actually enough to solve the problem. So if you see, the first 5 positions are here and the final 5 positions are here. So n minus 1 minus I is basically the sort of, it's kind of like the mirror reflection of some element on the other half of the array, right? So 0 corresponds to 9, and then the first corresponds to the second last, the second corresponds to the third last, and so on, right? So essentially, each of these numbers gets swapped with the corresponding number in the other half. So 0 gets swapped with 9, 1 gets swapped with 8, 2 gets swapped with 7. So without even, I mean, you could trace it, but just by observing what these 3 lines do, you could write down the output. It's going to be this. Or, well, the array is going to look like this after the loop is done. Then it just prints. So you would expect the output to look like this. Is that clear? Hopefully that wasn't too bad. Okay, I'll move on to the next question, and if anyone has any questions, I can revisit it. Right, let's look at this problem. So here we have 2 arrays, and some function foo is getting called here. On the 2 arrays. So the 2 parameters are themselves the arrays, and something is being done with them. So let's see what's going on. So first of all, it looks like the array values themselves are not being modified at all anywhere, right? You can't see any assignment with an array value as the left side. So the arrays are going to stay the same. You don't have to worry about that. Okay, so there are some variables here which you need to track, and that's it. Also, n1 and n2 are the lengths of A and B. So that's what they're there for. They're declared here, but they just represent the length. So whether they were parameters here or not doesn't really matter. That's all their purpose is. Okay, so first of all, flag gets declared to 1, I equals 0, and we have a while loop here. So while flag and I is less than n1. So flag is 1, which is non-zero, so it's true, and 0 is less than 2, which is n1. So initially this condition is true, and so this block of code executes at least once. This gets declared j, and you have a loop inside a loop. So again, don't get intimidated by any of this stuff. If at all you are struggling with loops during the semester, just evaluate line by line according to like the rules, and you'll find that you don't have to worry much about the other stuff. Like, oh, how does it work if like a loop is inside a loop? Just go line by line, and you know that uh, when you have a for loop, it works pretty much the same as an if. It attaches itself to the next line, and this if attaches itself to the next line. So the braces, if you wanted to add them, would look like this. Okay, so nothing to worry about there. Okay, so for j equals 0, j is less than n2 plus j. So this is the standard for loop that would run once for every element of the array with length n2, right? Which is just the second array, right? So it looks like this while loop is going for each element of A, and this for loop is going through each element of B. Just an observation. And at each iteration here, if they're equal, then break, okay? And the flag gets assigned to j is less than n2. Okay, so j is less than n2, what does it represent? It just represents whether this for loop ended because j was greater than or equal to n2, or it ended because of this break, right? If you imagine the execution of this for loop, j was equal to n2 minus 1. Then when this gets incremented, j would become n2, and then this would be false, and the for loop would end. In that case, if the for loop ended in that way, then flag would get assigned to false, right? 0 essentially. But if it ended somewhere in the middle, then j would still be less than n2, right? So the other thing that I observe here is that flag is keeping track of whether you found this condition to be true or not. And then regardless of all of that, I is getting incremented every time. Okay, now notice that flag is one of the conditions for the while loop. So if at all the for loop were to end in a way that it went through all of B without breaking, then this while loop would also end. Okay, so what does this function do then from all of these observations? So it's just checking if all elements of A are also in B. Or if you think of these arrays as sets, it's just checking if A is a subset of B. Why? So it's going through every element of A and checking if it's in B, right? So first of all, go through each element of A. That's what this loop is for. And then for each of those, search for that A element in B, right? So that's what this for loop is for. And if it's there, if you find it, then stop searching and record that you actually did find it by making flag equal to true. And in that way, the while loop continues to run. If you didn't find it, then flag becomes false. And then the while loop stops because one element of A not being in B is enough to conclude that A is not a subset of B, right? Then you would return the result, right? Flag, which is false, if that's the case. Make sense? So it's not just recursion. Sometimes you can see that clearly the code is written according to some logic to accomplish some purpose. And then if you're confident, you can just write down the answer, right? Is A a subset of B? Yes, it is. So just write down any non-zero, right? So, I mean, it would be 1 here, actually, not any non-zero, but yeah, it would be 1. One would, a flag would stay 1. How is flag changed to false? Okay, so basically, let's say that the first element of A was 1, okay, instead. So 1 is clearly not in B, so in this case, A is not a subset of B. So what would happen? This while loop would start with I being equal to 0, and with I equal to 0, this for loop would go through each element of B, and it would check if the current element that it's visiting is equal to 1, right? So A1I, which is A10, is 1, and A2J is basically representing each element of B. So this will never be the same because there's no one element here, right? There's no element 1 in the B array. So this part will never run. So then when do we reach line 17? It's when this condition becomes false, right? That's when the for loop stops. And this condition becomes false for the first time when j is equal to n2, right? And then just by like definition, like if j is equal to n2, then flag will become false. It will be 0. And then that means that the while loop also ends, and then that false, basically that 0 int value gets returned, right? So again, I'm using 0 and false interchangeably, but the flag variable is being used as a Boolean here, basically. So that's why I'm doing that. Okay, hopefully that's clear. Let's move on to the next one. Okay. I always find these problems annoying, but just in case they decide to annoy you guys, here is. There's nothing like super groundbreaking about this problem. You just have to see how to fit the existing structure to your logic. Also, I've written like whatever I've typed here is the code from the problem exactly as it is. So if you're wondering what this void is here, I got a lot of questions about this last time. It literally just means that main doesn't have any parameters in this case. If some of you recall command line arguments, which is like one of the last topics in the course, you can put some stuff here. We'll be covering that in the next session, but yeah, point is you can leave this empty, but you can also write void here. They're both the exact same, so don't worry about that. Okay. Okay, so here we have a for loop. I goes from 0 to 9 and j goes from 0 to 9 as well. So you can see that this pattern has, I mean, it's 9 long and it's also 9 tall as well, right? So you have 9 rows and 9 columns, looks like. Yes, it does. So clearly on each iteration of this for loop, we'll have to print a single character, right? Because there are 81 characters here and this is doing exactly that. But exactly how do we figure out based on this, whether to print a star or a dash? So it's just about stating this region in terms of the indices, right? I and j. So let's have a look. So first of all, I think it's clear that the logic for the bottom half, so this would be different to the logic of the top half. So I think, yeah, so here you can see, right, we only need to write down the condition required to print a star, and then automatically, if you're not printing a star somewhere, you're printing a dash. So you don't have to worry about that. So I would think of the condition here as something or something, right? So a condition for the top half and a condition for the bottom half, right? So the logic wise, I might check something like, okay, so this point, right, ij, so in the top half, and whatever logic that states that we are in this part of the top half, right, so the part where there are all stars, or we're in the bottom half and whatever logic for the bottom half. This is what the expression would look like structurally, at least the way I'm thinking of attempting it. Okay, so first of all, I mean, simple things out of the way. Let's see how to state that we are even in the top half of this pattern. So it's simply just that, so we can choose here I to represent the row number. It has to be that because after each run of this, you're printing a new line. So clearly the inner loop is responsible for one row. So then the I index represents which row you're on, right? So I is the row number, and the first row is row 0. So this is row 0, this is row 1, 2, 3, 4. So if I is less than or equal to 4, then we're in the top half, right? Now, based on the value of I and the value of j, we should be able to figure out whether to print a star or not. So where do we print a star? Let's see.